Welcome to the Internet of Things equation, a podcast when I talk about the Internet of Things domain both from the technical and business perspectives. I'm Łukasz Malinowski, the Internet of Things advisor and trainer. Is it possible to build a commercial IoT solution using open source components? What options should we consider? Can we self-host an IoT platform, or should we use the public cloud offering? Those are only a few topics we will cover today with my guest. He worked at NATO, Oracle, Cisco, and finally settled in the Eclipse Foundation as the program manager focusing on the embedded, IoT, and cloud computing, and edge computing, which is a perfect blend for our meeting today. Hello, Frédéric. Thank you very much for accepting my invitation.
Of course. Thank you so much for having me, Lucas.
Could you briefly introduce yourself to everyone listening and tell us how your IoT journey looks like?
At this point in time, I've been in IT for 25 plus years. And as you mentioned, I worked for several large organizations. At the time at Oracle, I was more in the development tool space. I moved to the mobile space. I went to Pivotal at some point, and I was in Cloud Foundry. So there's some kind of cloud expertise somewhere left in me. But really, my current role at the foundation as a program manager for embedded IoT and edge computing is about two things. First, we have 50 plus open source projects in that space. And embedded is just a recent thing. But if you didn't hear right before the holidays, the end of November, Microsoft announced that they are contributing Azure RTOS as Eclipse ThreadX at the Eclipse Foundation. So that's part of my responsibilities for the time being, because we are busy onboarding that. And at some point, maybe I will pass that particular part to someone else, or maybe move permanently to ThreadX and leave IoT and Edge to someone else. We'll see. But in any case, that's part of what I do now. The first part is about the open source projects. And the other part is about really being out there and let people discover those technologies, because you need adopters and you need contributors when you are an open source project. Sometimes open source developers don't have the time. So it's my job, so to speak, to be out there and bring adopters and bring contributors to them if possible.
Looks like you're a very busy man. And what you mentioned about the Eclipse Foundation, that it got a number of projects, even if we filter down to the IoT and Edge. Eclipse got a significant impact on the IoT landscape itself. So maybe could you briefly elaborate on the mission of that organization?
Absolutely. So the Eclipse Foundation was created in 2004. So we are celebrating our 20th anniversary this year. And originally, this was just about the classic Java desktop IDE that everyone loves to hate at this point. Although we have, millions of downloads every month. So, I'm saying that, but it's quite an active community. But it's just a tiny fraction of what we do. We diversified a lot over the years. And in fact, the first step in that diversification process was literally the creation of Eclipse IoT, our IoT working group, in 2011. So we've been, around there for several years. To me, Eclipse today is really a broad assortment of open source technologies that cover everything from the cloud with Jakarta EE and the Adoptium working group that puts together the releases of the Temuran Java virtual machine, if you're into that, and then all the way down to the microcontroller with Eclipse ThreadX at this point. What's impressive about Eclipse is that what we do is literally just this. We are a nonprofit hosting open source projects, and we are financed by the annual fees that our members pay. And with those fees, we provide open source projects infrastructure, build servers and everything that they need on one side. And on the other side, we have a number of staff members, and everyone on the staff is working directly or indirectly in support of open source projects. And that's our mission. We don't do commercial things. We are just this vendor neutral place where people can come and collaborate on open source projects. And the thing is, we say open source, but, not every open source is the same, in the sense that, you have a random guy in his basement putting something on GitHub. That can be open source. That's good. But that's not the same as, let's say, things like Kubernetes or Kubernetes is the CNCF. So it's like we do. But let's say Golang or single vendor projects like Spring, for example, where you have one organization at the top that can make decisions. So that's a bit better than the random guy on GitHub, but still there's one party at the top that can go counter to what the community does. We don't do that at Eclipse in the sense that an Eclipse open source project is really vendor neutral and is the property of its project lead or leads. In certain cases, you can have multiple leads and the committers. And me, as the program manager for embedded IoT and Edge, I don't have authority over those projects or anything like that. I'm not there to tell them what to do. If they want my advice, sure, I can give it. But ultimately, they decide their technology direction. They decide where to go. And we just support them in the process. And that's really important because then, since we are this vendor neutral third party, what we do is that we ensure to maintain a level playing field among contributors. So you don't have to deal with IP problems, you don't have to deal with governance problems, because we have frameworks in place and processes in place that ensure that you can benefit from that. So even for someone who is new to open source and wants to open source a project, we are a good place because we have services that you can take advantage of. And anyone can literally create an open source project at Eclipse. It's very simple. We feel, along with Apache and other similar organizations in the space, right, that we provide value to the open source community.
Speaking about vendor locking, because you mentioned that a few times, a question that I've got from my customers that they are a bit worried about being vendor locked. Do you think that going through the open source movement, leveraging Eclipse organization, is that valid answer to risk of being vendor locked?
Yes, because essentially every project that we have is something that you can either host yourself or even build a cloud service around and then can offer it to people in the field. But to give you a perfect example of this scenario, one of our important members in Eclipse IoT is Bosch. And Bosch, a few years ago, I think in 2017 or 18, they started to offer something called the Bosch IoT Suite on the web. A number of cloud services, they were built on the top of open source projects that Bosch started. The cloud service had a nice user interface and support and things like that. But underneath, it was a bunch of Eclipse open source projects. And the thing is, they decided to discontinue the platform. They announced that last year. They are exiting that particular market. The projects will continue. In fact, they are quite healthy because over time, Bosch itself has found a way to attract new contributors to the platforms, and they will continue to use them in other products or in other projects. Inside Bosch. But the thing is, you have a migration path. What Bosch did with the help of some of our members, like Sotec in Germany, what they did was literally to migrate those people to the open source version of the projects hosted on specific cloud providers. This wouldn't have been possible if it was just a software as a service offering that the provider kills. And we know a number of players in the market, that love to kill their offerings and things like that. This doesn't happen when you adopt our technology because essentially you can host it, you can ask someone to host, and of course there's a thriving ecosystem around it.
Speaking about commercial grade software, is it possible to build a commercial IoT solution using open source components? It looks like a challenging task because you've got lots of those moving blocks that you need to put into proper places. And some customers that I talk with, they tend to buy like whole package from one vendor because goes like in opposite direction to the vendor locking, right? But they do not have the internal IT department that can help them to design and build that IoT solution using open source. So what's your take? Like how hard is it to actually build the commercial grade IoT solution on top of open source components?
I wouldn't say that there aren't challenges there, but it's a bit easier than what it seems. But of course, it all depends on which project specifically you consider. Nearly all of our members contribute to one or several open source projects at Eclipse and have their own commercial products on the top. A good example of this is Eurotech, a maker of IoT devices. They have gateways, they have edge nodes and things like that, and several other things. And they have software offerings as well. And they have their commercial offerings in the cloud that they offer, but all of that is built onto Eclipse open source projects that were started initially by Eurotech. You can run with the open source version, specifically of the Eurotech-led projects. We're talking about Eclipse Cura, which is a solution for IoT gateways. So you buy any generic ruggedized device, you install Linux, you install Cura on it, and wham, you have already a fully functional gateway that supports multiple protocols and things like that. And on the other hand, there's the Eclipse Kapua project, which is the cloud complement to your gateway solution, in the sense that Kapua can administer gateway devices in the field, push software updates to them, do data management to aggregate the data from multiple gateways and things like that. Eurotech have commercial offerings if you need the support, and they will be happy to sell that to you, and the products are great. But you can simply start with the open source projects as well. And if you have a minimum of IT people on staff, they will be able to go very, very far with that. Whether this is a viable solution or a viable path for your organization, using directly the open source project versus going commercial and having the support, that's something that only you can decide. Of course, you need a minimum of expertise, but I would argue that with the maturity of the projects that we have and the extensiveness of the toolkit that we have, that it is quite possible for most organizations with a minimum of IT people on board to build something successfully on your own using our open source projects. And many people do, by the way.
Could you give us some idea of what do you consider to be the minimum IT staff, and what type of skill set those people need to have in order to leverage your solutions, basically to build a platform? I'm not saying about fine-tune it or contribute to the development, simply to use those building blocks to provide the business value for the company?
That's a very good question, and it will all depend in the end on which projects are the most relevant to your particular deployment. Projects that we have are implemented in a variety of languages. They are running on a variety of operating systems. Identify the perfect skill set, but at the same time, it all starts with at least one good IoT architect with some experience and some expertise, right? If you don't have at least one person on staff who's knowledgeable about those things, they can make the right choices, then it's a bit more difficult. Of course, you can talk to people like you. People watching can talk to Lucas and other people that provide those services to organizations. So even if you don't have people like that internally, you will find them in the market to advise you in the ramp up of your particular project. As a former teacher, what's important there is not necessarily the current skill set of whatever developers you will have. You will need a few developers, of course, but rather their potential, in the sense that even if someone is not fully experienced in Python or something like that, if they are a bright developer, they will learn really, really fast. So once again, the role of the IoT architect there is key, because he is the one who will point those people to the right protocols and make then the right choices about languages, toolkits, tool sets, and that kind of stuff. With a minimal team of an architect, a few developers, you have already a good base, because that's the thing. You're not building everything from scratch. You are using building blocks in order to have a comprehensive solution. And so if you work incrementally on a minimal viable product and then expand outwards, then, a team of a few team members, let's say one architect and 3 or 4 developers would go a really, really long way in order to provide a proper solution to the organization. And if you don't have those internally, once again, there are multiple organizations that you can deal with to provide that kind of expertise as well. The key thing there, however, is if you go open source, this is a bit counterintuitive, but if you go open source, of course, you can download everything for free. You can consume everything for free. And then you could think, oh, I will leave it at that. But then comes the question of support. How can you get support if you are using something for free? Well, the key thing there is that you should start contributing to those projects in some way. Maybe it's a bit of documentation. Maybe it's a bit, a few bug fixes as you stumble on them and your team gains expertise. And the key thing there is that when you're part of the family, when you submitted, patches or questions or bug reports, and you are involved in a community, people will help you in the open source world. And in fact, it's the same with product or project roadmaps. You need a new feature. When you're part of the family, if you worked on the code, people will listen to you. Otherwise, it's a bit more difficult. But I would argue that it is much easier when you are contributing to an open source project to convince the rest of the team to implement a feature that you need, that to convince a product manager in a commercial organization to implement whatever feature you need in a commercial product. Because in this case, they will consider profitability and roadmaps and things like that. And it's not the same community-oriented spirit. You are in a commercial transaction, and people have a tendency to forget that.
I love your comment about contributing to the documentation, because you don't have to be like the hardcore developer to contribute to the documentation. And on the flip side, most of hardcore developers I know, they really use source code as a documentation, and they then don't care about, writing and explaining the genius zone, basically, right? So if you are just a company leveraging tools that you provide, you can give back to the community by improving the documentation, because that might be the area that you can actually provide a huge impact, right? No one expects you to be a developer or to write to code in order to give back to the community.
Yeah. And I said specifically documentation because this is the easy point. But maybe at some point you developed expertise around a specific project, for example. Then if you have some sort of internal training, well, maybe you can contribute to the community as well. And so it's not just documentation, it's training artifacts, or even letting the developers know that you use their project. Right. So we have this, what we call the Eclipse IoT Adopters Program. And this is a page on our Eclipse IoT website on ioteclipse.org/adopters, where companies can put their logo there to say, oh, I'm using this project and I support it. Just that is tremendously useful because it shows to potential adopters of a project that they are not the only ones with an interest in this project. And just that is a little something that you can do really easily to support the community.
Giving that support to the developers, that actually someone is using the stuff that they provide, that's a huge, right? For me as a developer myself, I know that whenever I get a feedback that what I provide actually makes sense, like it really makes you to do your best, right? To contribute and push
Indeed.
forward. And thinking about skill set, we've got a question regarding the security. Is there a security platform, or how can someone that owns the PKI infrastructure, for instance, to integrate with Eclipse solutions?
Yes, but then, of course, since those are not commercial offerings, then you have a bit more of a manual tinkering sometimes. All of the basic infrastructure to integrate with your certificate infrastructure is there. However, there's no, let's say, simple to use UI that ties all of that together, especially since in our case, our open source projects are independent building blocks. They are not necessarily developed with each other. So they implement de facto standards in the sense that the standards are not necessarily written, but everyone is implementing, the same technology there. What I would say about this is that it is perfectly possible to implement comprehensive security workflows using our stack. So a good example of this is device attestation. You want your devices to be trustworthy. And device attestation is literally using a chain of certificates in order to attest, hence the name, that every component in the chain is uncompromised or has not been tampered with. So this starts by applying digital certificates to the kernel of the operating system that you are running on the device, and then every software component and every application on the top of that. So you having your own internal KPI infrastructure is a good step into that, because you will have lots of certificates to generate. You may want to deal with external third parties that offer services in order to simplify the provisioning of their certificates and things like that. So there are solutions in that space. We don't have open source projects around that currently. Since device attestation is becoming increasingly important, then of course down the road we may expect those things to become commodities, and then it makes sense to have an open source project around them. An important dimension there as well is that security is not just about the technical aspects of security. So of course it's important to use TLS or DTLS and encryption at rest and in motion and things like that. But there is also the software supply chain that needs to be secure. And here we are going back to what I said about varieties of open source. Not everything in open source is the same. So at the Eclipse Foundation, one of the services that we offer is cybersecurity. And by that, we mean that we have secure development practices that we are pushing our projects to adopt. And this means that because of the IP processes that we have, the intellectual property processes that we have, when you download an Eclipse component, you are sure that there are no problems in the licenses of the dependencies of a specific project, for example, and that everything, we can identify the origin of the code, whether it's been written in the Eclipse project or the third-party dependencies. This is really important because then you have a software bill of materials which is verifiable, which means that you know exactly what's in there. And so if there's another incident like what happened with OpenSSL a few years ago, or even Log4j in the Java world more recently, it was a worldwide problem for several months for everyone. The next time a thing like that happens, you will know instantly if you are affected or not, because you have a fully detailed software bill of materials. The Eclipse intellectual property team verified the origin of the components, and so you can download and use that without having fear that you will get legal trouble down the road. There's no guarantee like that, even with single vendor open source, because they don't necessarily care about it. And certainly a random library on GitHub will not provide you the same level of confidence. And so for us, this software bill of materials and the other cybersecurity services that we offer at Eclipse are another advantage that we have as an open source community. And at the same time, this gives you additional confidence in our projects. Don't forget about this, right? The technical aspects of security are important, but your software supply chain is important as well.
Totally. And for enterprises, I believe that might be even more important, right?
Yes.
And
Yes.
the licensing part, I got number of stories myself when I lost my hair, basically because of the licensing. You use some library that's got library inside and whatnot, and at the end of the day, you've got some licenses that you are not allowed to use in that specific case. The software bill of materials handling the licenses, I believe that's a huge gain for enterprises. How long does it take, based on your experience? And I know that every case is different, but just the order of magnitude. So how long does it take to build the MVP, the minimal viable product of some kind of IoT deployment using Eclipse open source components?
Well, typically an initial deployment, especially if you take the wise approach of starting small and simple for your MVP, is something that you can probably do in a matter of months. Now, whether this will be 3 months or 9 months will depend, of course, on the scale at which you are operating, the type of hardware that you are using, the level of maturity of your organization, the level of experience of your developers. So there are many factors at play there. But certainly, it's possible to be up and running in a matter of months, especially if you use the most advanced building blocks that we have in the Eclipse IoT toolkit. One thing that's interesting is that even though in the case of IoT, we are past the buzzword phase, I mean, IoT is still around as a term, but it's a bit less trendy than it was, let's say, 5 years or 7 years ago. And with good reason, because there are cycles like that in the industry. People are excited about other things at this point. However, this means we are in the realistic phase where we can actually build things because the building blocks are available, they are mature, and at the same time, there's still tremendous potential in what IoT, industrial IoT can deliver. From that perspective, the type of project that you will tackle today is maybe a bit different than what people were trying 5 or 7 years ago. Initially people were happy to just slap a few sensors on a Raspberry Pi in a random enclosure, put that, and hey, we're doing IoT. Nowadays, you have a whole slew of ruggedized devices that are generic that you can buy. You have a mature open source projects that you can deploy. Of course, the sensor ecosystem grew tremendously in the last few years. So you have lots of choices, which means you can be a bit more selective about what you do. And you have plenty of material out there to give you inspiration about what you can build. We are past the point, I think, where you can do straight IoT to the cloud, in the sense that people realized fairly early that doesn't necessarily scale, it's not necessarily flexible. And there's the whole dimension of data sovereignty, in the sense that your IoT data tells a lot of things about the internals of your organization. So maybe it's not a good idea to store all of that in the cloud from a specific vendor, especially since you will be tied to that specific vendor. And you personally, I think, are quite, quite aware of that particular dynamic, given your resume. So, the thing there is really the role that edge computing plays in all of that, in the sense that most IoT deployments today will have some sort of edge computing in order to aggregate the data locally and maybe anonymize it before sending whatever is relevant to the cloud, so that, of course, you take advantage of cloud services. I'm not saying the cloud is bad. I mean, I've been in cloud services, you've been in clouds. It's perfectly fine. But edge computing gives you the possibility to keep everything that's strategic to your organization in your own premises, or maybe in a local data center closer to your multiple sites that you have in a specific country, for example. And this is increasingly important, especially with regulations coming from the European Union and other large international organizations, where in some industries you need to guarantee that the data about patients in healthcare, for example, will not leave a specific hospital, will not leave a specific region or country, etc. So all of that is made possible through edge computing. So my recommendation there, of course, if you're starting, is to consider edge computing an integral part of the architecture from the very beginning. Or maybe you do your minimal viable product about the sensors and all of that, but really don't deploy that into production without some measure of edge computing.
I believe that edge computing solves a number of challenges, and some of them you just pointed out, like the privacy, for instance, right? And IoT used to be a hype. Then people got a bit concerned about the privacy, security, and so on. And we could use the edge logic, the edge compute, to actually provide that security, privacy, while extending the capabilities for the end user, right? So it's like win-win scenario. And the side benefit is that we reduce your connectivity and cloud infrastructure costs, because you moved as part of those computation power from the cloud to the edge device itself. I totally agree with you. This is something that I recommend my customers as well. If that is applicable, think about how you can leverage edge computing, because that will be the win-win scenario both for you and for your customers. Speaking about that, that's a great segue, because some time ago we saw a huge trend to move into the cloud. Like, major companies were very happy to move into the cloud. Lately, we saw a few companies decided to move out of the public cloud infrastructure. Is it possible to self-host an IoT platform, or we've got to use that cloud because cloud basically offers the infinite compute and storage capabilities? Self-hosting got all of those nasty little challenges like the server patching and all of that, and you need to scale to meet the demand. So based on your unique view, do you see that self-hosting IoT platform is actual option, or it's better not to go that way?
Self-hosting is definitely an option there. It requires maybe a slightly different type of team in order to pull everything together. But really, realistically, it's definitively an option. The thing with cloud, it's a funny story. We say it's nearly infinite, but in fact, in a previous job, I had a little friend that I was working with in a partner organization. And essentially, at some point, they were using so many VM instances of a specific type on their cloud provider that at some point they were getting error messages because no more instances could be started in a specific region. And that was a big problem for them. So we implemented patches in our stack in order to manage those conditions when they were happening and selecting alternative instance types maybe to provide still the service. So the cloud has plentiful resources, but you can exhaust them if you are really, literally crazy and want to get a crazy bill at the end of the month. You're right to point that many people have stepped back from the public cloud in the sense that initially it was very cheap. And now, of course, the business models of the cloud providers firmed up a bit. And so the pricing is not always the most beneficial for you, especially if you're using a value added service like, an IoT cloud service from a specific provider. We won't name names there, but yeah. The thing there is that the Eclipse projects that we have that are relevant for IoT and edge computing have fairly extensive feature set, which means you can deploy those wherever you want. You deploy that on premises on your own servers, you deploy that in your own private cloud, or you even use an hybrid model with local instances in your private cloud and instances in the public cloud as needed. And you can mix and match. That's the type of flexibility that you don't have when you go straight for the specific IoT service of a specific cloud provider. This means that you would have to manage your own virtual machines if you host some of those projects in the public cloud. And this is a bit more work, let's say, than the managed services from a provider. But people increasingly realize that nothing is really free, and maybe that the very cheap prices of the cloud initially were there to foster adoption. But those cloud providers have to pay bills for their IT teams managing their servers on your behalf, and they need to tackle profit margin on the top of that. In most cases, it's cheaper to do things yourself in the end if you can recruit the right people. From one organization to another, there are nuances there, there are differences there. Maybe you can negotiate a great deal with your cloud provider, but don't forget, read those contracts. They can change the price at any time.
I think that's a great point, that there is nothing, not such a thing like a serverless. There are servers, someone needs to manage those servers, and someone needs to pay salary for those people, right? And those are highly trained experts. They are not like someone who doesn't know what they are doing. Serverless or serverless IoT or whatever, we've got servers. The only question is who is managing those servers and who is paying salaries for those experts. You just need to do the math, as you said, right? Sometimes it's good to start with some out-of-the-box offering. And this is actually something that I recommend for the customers that have no experience with IoT domain itself. So I'm saying start with something off the shelf that won't be perfect, that won't suit your needs totally, but you will at least learn the basic use cases. Yeah, you will list the basic processes. Once you understand all of that, then you will be ready to design your own solution. Right? Because starting from scratch and trying to reinvent the wheel, that won't make any good for you. Like you will, at the end, you will lose time and money. So just start with something off the shelf.
This is very good advice. And in fact, it highlights that you should start with the application. What's important to you is not the technology. What's important is whatever data you want to gather and whatever service you want to deliver, well, inside your own organization or to your customers and partners, depending on what type of business you have. By using off-the-shelf services, off-the-shelf components, you initially focus on the use case and application, as you said. And once you have reached maturity, then you optimize the cost and deployment model and things like that. Yes. So very good advice.
Yeah, exactly. Focus on the business value, not on the technology. Because for me,
Exactly.
I love technology because it's just playful for me to interact with it, right? But I know that the technology itself does not provide any value at the end of the day. Like IoT is just the enabler. Like it enables to generate some additional value, and that's why starting from application, as you said, from the value that we want to provide, and then basically working our way back to the technology, like the minimal technology required to obtain that. There is an ongoing discussion in the IoT space that build versus buy mindset. Eclipse offers those components. Do you think more of the buy or build mentality when you speak with your customers or partners and propose that they might consider using Eclipse components?
Yeah. And in this case, my advice would be either to buy something which is built on open source or build your own using open source components. Of course, I have a little bias there. I'm working for an open source organization, but I think from a strategic perspective for most organizations, this is the choice that makes sense. Maybe you will find the perfect IoT platform for your needs as a purely proprietary product. You invest in that for a number of years, and then what? If the vendor is bought by a bigger company, will they maintain the little platform that you are using or migrate you to something else that you won't like? If you buy into a proprietary IoT cloud service from an hyperscaler, what prevents them from changing the price, changing the feature set, killing it at any time, and then what once again? So we have, in fact, multiple examples of that because in the latest years, I gave the example of Bosch that killed IoT Suite. But in their case, since it was built on open source components, you had a migration path. But other players did the same. Google IoT Core is dead. Watson IoT from IBM is dead. SAP IoT Cloud is dead, and all of that. And not all of those user bases, I don't want to point fingers to a specific vendor. And of course, those companies were right if they didn't have a sustainable business model to exit the business. But some of those users had a migration path, and some didn't. And the ones with the migration path are the ones that use products that were built on open source projects that were managed by a vendor neutral third party like us. And the others, well, they are scrambling right now because that's the nature of the commercial world. So, really, if I was having my own business, especially if IoT is strategic to my business, ensure that I depend on a platform that gives me the flexibility. And so, with an ecosystem of commercial companies that can give me support and commercial products if I need that, but with also the option to go pure open source or to be part of the open source community, as I said, because ultimately that's the right way to do open source, not just consume, but participate and contribute. And then you get support from the community, and then you get value, and you make more sustainable the technology that you depend on. With a commercial company, that's the thing. Apart from giving them more money, you cannot make them more sustainable. And you have no guarantee that the project that you are depending on will live. With open source, if you dedicate development resources to an open source project, you are literally making what's important to you more sustainable over the long term. And from a sustainability perspective, that's important too, in the sense, if you look at planet, we are trying to make the world more sustainable right now in terms of the way we consume resources and all of that. When you use open source, you are literally helping sustainability because you are using code that has already been written, debugged, and all of that, which means that you are preventing people from reinventing the wheel and wasting electricity and time and other resources on reinventing the wheel. And that's another dimension. So if you care about the planet, open source is the right way to do it.
Reinventing the wheel. That's such a great point. I remember, like, based on my own example, a few years back, or my maybe a bit more than a few years, I used to be the PHP developer, and I had the mindset that I need to write everything myself. Like that was just something in my brain that I was not willing to accept any open source library. I wanted to write everything from scratch, and I learned my lesson. Reinventing the wheel doesn't make my project any better, and actually I'm putting the whole project at risk because I'm spending time on something that is already available. The example that you gave, that some hyperscaler closed their IoT offering, it's pretty nasty place to be in once you've got your customers that you need to basically change the whole backend while you are in flight, right? The plane is already in flight, and now you need to just change engines because they are not working anymore. That's
Yeah, I
yeah,
wouldn't recommend that.
that's pretty scary. So
Yes.
I've got to ask this question because there are tons of Eclipse projects. What's your favorite project and why?
Oh, this is an unfair question in the sense that my job is literally to love them all and promote them all. But
I
let's say
know, I know.
let's say I have a number of projects that have great momentum right now, and certainly that are worth the attention of our audience today. Of course, Eclipse Cura and Eclipse Capua as a duo, a very mature code base with an exciting feature set, they are certainly worth your attention. We also have protocol implementations for all of the major IoT protocols. So we've got Eclipse Paho and Eclipse Mosquito and Eclipse Amlin in the MQTT space. So Paho is a collection of MQTT clients. Mosquito is a lightweight MQTT broker. And Amlin is an enterprise-grade MQTT broker that was the core of Watson IoT in the past. If you need to have millions of devices connected in real time and high availability failover, things like that, Amlin will deliver that to you. Then, of course, we have Eclipse Californium for CoAP. We've got Eclipse Lesson for lightweight M2M, etc. One interesting thing is that we also have a DDS implementation, if you care about that, and it's Cyclone DDS. However, DDS has a number of issues dealing with the public internet. And so what happened is that people with deep DDS knowledge at Zetascale, one of our members, decided to rebuild DDS from the ground up for the modern era, and that gave birth to Eclipse Zeno. And Zeno is really a fantastic protocol if you're starting on a new project right now. It's publish and subscribe, but you can do peer-to-peer. You can do routed because there's the concept of routing node in there. It manages distributed storage. It's really awesome technology, so have a look at Zeno. We have a number of mature projects that were part formerly of Bosch IoT Suite and provide enterprise-grade infrastructure. So Eclipse Hono, which is device connectivity, a really fantastic platform. We've got Eclipse Ditto for digital twins, very, very strong projects with good adopter community. We've got Eclipse Hawkbit, a very popular platform to deploy software updates. And once again, those work well together since initially they were developed together, but they are independent. So you mix and match whatever you need for your particular deployment. There are many, many others, but one last project that's really exciting that we've got is something called Sparplug. So Lucas, you're familiar with MQTT. So one of the great things about MQTT is that you can publish anything anywhere. One of the bad things about MQTT is that you can publish anything anywhere, and that's a problem. So what happened is that Alan Nipper, one of the co-inventors of MQTT, he's got a company now called SiriusLink Solutions. And in 2016, he invented something called Sparplug to solve the problem of the lack of interoperability in MQTT. He realized that it wasn't easy to build a community around this. So in 2019, he contributed Sparplug to the Eclipse Foundation. So Sparplug defines 3 things to make MQTT devices interoperable out of the box. The first thing is standard payloads. So it's a Google protobuf schema that defines payloads that can express any metric or set of metrics. So that way, every participant in the infrastructure can parse those payloads and send messages using the format. At the same time, they are not tied to any specific data model, so you can express whatever you want. If you want to use the OPC UA information model in there, you are welcome. You can do that. If you want to use your own custom data model, you can do that as well. The second part in Sparkplug is the topic namespace. So essentially, the topic structure is predictable because it's built in a very specific way, which means out of the box, you know where to publish or subscribe to the information. And then the last part is what we call stateful session management. One of the big problems in industrial automation is that you have to poll devices typically to determine if they are online or not. And you poll and you get a response, and you waste bandwidth and time using, doing just that all the time. So with Sparkplug, we use some features in MQTT that's mandatory to ensure that devices publish a birth certificate when they come online, announcing the metrics they will report about. And when they disconnect, voluntarily or unexpectedly, they send a death certificate. And between the two, you're sure that the device is online. You don't need to check it. Because of all of that, Sparkplug is really interesting and solves very specific issues in industrial automation, and make it much easier to get this industrial data in your IT systems in a streamlined way and up to the cloud as well, since this is plain MQTT. So, it's much better than OPC UA from that perspective. Sparkplug, it's an open specification at Eclipse. Anyone can implement it, and there are a variety of open source and commercial implementations. But what's great is that recently we made Sparkplug an international standard. So it's also known as ISO IEC 20237, rolls off the tongue, I know. What's great about this is that we successfully transposed Sparkplug as an international standard. And so you have this recognition of the quality and maturity of the technology, even though it's still fairly young. So in any case, Sparkplug is really exciting because it's a lightweight alternative for industrial automation that solves actual problems in the field. That's, let's say, the list of the most exciting projects that we have, but we have 50 plus of them, and really, I don't play favorites. My job is to help them out.
Well, yeah, so that was quite a long answer to give one favorite. My personal favorite, to be honest, is Mosquito. I use it mostly during trainings and prototyping, and I love it because it's so lightweight, and basically you can show the whole MQTT session to everyone attending your training, so people understand how it works under the hood, and they can really understand the differences in the quality of service levels, for instance, in MQTT, which is huge. If you want to be architect and developer in the IoT field, you need to understand that inside out.
Absolutely.
So if anyone from the audience missed the project, this is the book that Frédéric wrote. Let me try this. Yeah, it's not an advertisement. I'm really a huge fan, and I think that's a great source of knowledge about open source IoT components that you can use in your commercial IoT platform. Let's wrap up. Frédéric, what's the best way for everyone listening to stay in touch with you and to follow you to know more about the IoT and open source IoT components of Eclipse?
So, of course, you can reach out through my LinkedIn, for example. So that's an easy way to find me. I'm on X. I'm on Blue Sky at this point. I have a brand new account. Anyway, you can find me everywhere. And of course, if it's easier for you, just drop an email to iot@eclipse.org. So I'm monitoring that alias and be more than happy to strike a conversation. Of course, we have a Slack instance for Eclipse IoT that you can find, and there are multiple channels, but don't hesitate to reach out. Really, my job is to ensure that you, as a developer or architect, can find the right Eclipse projects that will help you out for your particular implementation. So that's part of my job. So if you're not sure where to start, and we have a list of projects on the website, but that's intimidating. So if you don't know, we can sit together and I can provide a bit of advice about where to look. And of course, Specifically about protocols, I wrote 2-part, now soon to be 3-part article for RT Insights that you can find, and that explain in detail how to pick your IoT protocol. So that's another good resource that you can look at.
Thank you so much, Frédéric, for taking time to meet with me today and providing your insights. I think that was an extremely interesting conversation, and thank you for your contribution to the open source IoT space, because I believe that's a huge, huge thing.
Thank you very much. And once again, I'm grateful for this opportunity. Thank you.
Thank you for listening. Go to the Frrics.com to find more materials about the Internet of Things domain. My name is Łukasz Malinowski, the Internet of Things advisor and trainer.